Your lecture is about determinants. You're having a matrix A which is of order 2 by 2. So first we have to find out the determinant of a matrix of order 2 by 2. First you will write the matrix given entries in the form of determinant form, and the determinant of a matrix of order 2 by 2 is the subtraction of the product of the diagonals. That is, first diagonal is A11 times A22 and the second diagonal is A21 times A12. Now actually our task is to find out the determinant of a matrix of order 3 by 3. Here you're having a matrix A which is of order 3 by 3 and it is a square matrix. So how will you find out its determinant? First you will write the three columns. First column is 0, 3, 4. Second is 2, minus 1, 4. The third is 1, 2, 1. You will again rewrite first and second column from the question. Now after writing the two columns from the question, how will you find out the determinant? Now see, you are having three diagonals in the forward direction. In first one is 0, minus 1 and 1, its product is 0. Second diagonal is 2, 2, 4, its product is 16. The third diagonal in the forward direction is 1, 3 and minus 4 and its product is minus 12. Now I will again write the given question with the repeated first and second column. Now I will have three diagonals in the backward direction. First diagonal is 4, minus 1 and 1, its product is minus 4. Second diagonal is minus 4, 2, 0, its product is 0. And the third diagonal in the backward direction is 1, 3 and 2 and its product is 6. So now the forward diagonals, they are having product 0, 16, minus 12. And the backward diagonals, they are having the product minus 4, 0 and 6. So how will you find out a determinant of a matrix of order 3 by 3? You have figured out the products of the forward diagonals and backward diagonals. So you will subtract the answers of the forward diagonals from the answers of the backward diagonals and the answer will be positive 2. Next, you are having the topic how to find out the determinant of an upper triangular matrix, lower triangular matrix or diagonal matrix. So we'll start with the question. Here matrix A is given, which is a square matrix, and you are asked to find out the determinant of this matrix. As you can see that the non-zero entries, they lie below the diagonal. So this is your lower triangular matrix. So how will you find out the determinant of a lower triangular matrix? You will just multiply the diagonal entries 2, minus 2, 1 and 3. See over here, determinant of A is 2, minus 2, 1 and 3 and the determinant is minus 12. In second question, you are having a matrix B and it is just a diagonal matrix because only the diagonal entries, they are non-zero. So how will you find out the determinant of this diagonal matrix? You will just find out the product of the diagonal. Minus 1, 3, 2, 4 and minus 2. The product of the diagonals will give you the determinant of a diagonal matrix. Now sometimes finding out while you are finding out the determinant of a matrix, there are some conditions which are to be kept into mind, which makes the determinant equal to 0. Now first thing is that the matrix has to be a square matrix. Now what are those conditions under which the determinant becomes equal to 0? Now here, as you are having a determinant 2, 4, minus 5, 0, 0, 0, 3, minus 5, 2. So while solving a question of a determinant and while solving there are rows of zeros, then that means that the determinant of that matrix is equal to 0, as you're having an entire row of zeros in a determinant. Second one, in the determinant, the entries are 1, minus 2, 4, 0, 1, 2, 1, minus 2 and 4. Here again, the answer of the determinant is equal to 0. The reason is that the two rows, they are identical to each other. The first and the third row, they are identical to each other. They are same. That's why the determinant of this matrix is equal to 0. There is third case as well. Now see this determinant. The entries are minus 1, 2, 2, 3, 6, 4, minus 3, 6, 6. The determinant for this is equal to 0. And here the reason is that first row is actually a multiple of the third row. That is the reason the determinant is equal to 0. Again, I'm repeating it. Under what three conditions you can have a determinant equal to 0? If in a determinant you are having a rows of zeros, then its determinant is equal to 0. If in a determinant two rows are same, then its the determinant is equal to 0.